This is Joel Mendonça, and I'm back with another video on a very important topic called VPNs, right? And I'm going to concentrate the configuration part of it mainly in this video. You can go back and read about VPNs, how VPNs actually operate and the various phases involved and all of that, and then you can come down here and look at the configuration to actually get a hands-on, right? So I'm basically doing this on a GNS3 emulator, right? Let me just brief about VPN and what I'm trying to establish in this entire exercise. So we have two routers here. In fact, we have like 4 routers, and I'm using my R4 router to be a ISP, right? I'm emulating a ISP using my R4 router. And the other routers R1, R2, R3, right? These are the routers where we want to establish a VPN. So I'm going to establish a VPN between R1 and R2 and R1 and R3, right? And when I say VPN, I intend to have a secure VPN, which means I need to use a protocol IPSec, which would help me do that, right? So IPsec protocol, IPsec VPN is basically it has 2 different phases, right? The first phase basically is called ISecEmp, and the second phase is where we use the ESP protocol, right? The ISecEmp, which is used in phase 1, is a UDP based protocol. It operates on port 500, which helps you to establish the first tunnel and this tunnel is used to exchange the keys, exchange the Diffie-Hellman keys, which in turn will be used in my phase 2 tunnel to actually encrypt the data, right? So that's our final goal. Our final goal is to encrypt the data and securely transmit this data between R1 and R2 or R1 and R3, right? And to do that, we need to do it in 2 phases. The first phase is the ISecEmp phase, and the second phase is the ESP phase. So in the first phase, I generate my Diffie-Hellman keys and I exchange these Diffie-Hellman keys between R1 and R2 or R1 and R3. In the second phase, I use these keys which are exchanged in my phase 1 to actually transmit the data. Now, why are we exchanging the keys? Because we are basically using something called a symmetric encryption, and in a symmetric encryption, we want to have the same keys at both R1 and R2, because R1 is going to encrypt some data using certain keys, and then R2 need to decrypt the data using the same set of keys. And that's why we are exchanging securely these session keys in phase 1, and then we use the same keys in my phase 2 for decryption, right? So that's basically a very quick refresher on what we're trying to do. And yeah, I would strongly advise you to look at the Cisco guides to understand the protocols in a more detailed way, especially the phase 1 ISecEmp protocol and the phase 2 ESP protocol. Yeah, so let's get started with the configuration, right? So let's start with so I'm as you see, the configuration R4 is basically an ISP. So let's start with configuring our ISP, right? So let's okay, so let's start our nodes, right? So I've started my nodes. Let's pull out R4, right? Let's also get the console for the other routers as well. Great, so we have everything here. So let's start with R4, right? So what are we trying to do on R4? We need to configure the 3 interfaces, the 3 serial interfaces which you see down here, right? Which means let's start with that. So let's start with configuring interface serial 2/0, right? Let's put a IP address on that. What do we use, right? So we could use 192.16 it's not 68, okay, 1.10.4, okay, 255 and 0, right? Let's do a no shut on that. So that's good, which means I have configured this interface to be 10.4, right? Let's do a 20.4 on this interface, right? So which would basically be interface serial, which is interfaces 2/1, right? And IP address being 192.1 dot, let's do 20.4, okay, 255.255.0, and let's do a no shut as well. And let's also repeat the same thing on the other interface, which is downwards, and that would be interface serial 2/2. Let's put an IP address on that, which would be 192.1.30 and .4, right? So let's do that. I think we are done, right? So if you look at do show IP interface brief, you see that we have configured three serial interfaces. Couple of them are down now because we need to configure the other side, but this is how it actually looks, right? So let's move on to configuring R1 now, right? So on R1, let's start with configuring the serial interface 2/0, right? So let's do that. 2/0. Let's put an IP address on this, which would be 192.1. Let's use 10.1 probably, right? And let's do 255. That's the wildcard mask, subnet mask, my bad. And let's do a no shot as well, right? So we did that. Let's probably put up these two networks as well while we are here. We could do that, right? So let's go to interface loopback 0 probably. Let's put an IP address of 10.1.1.1, 255.5.0 and no shut. Let's also put the other interface, other loopback, which is loopback 1, and the IP address is going to be 10.1, I mean it's 11.1 probably, 255. Subnet mask is compulsory, no shut. So we have set up the loopback interfaces, we have set up this interface. Let's also put a default gateway on R1, right? So that let's direct the default gateway to be R4 because that's our ISP, right? So how do we do that? Let's use the command IP route, right? 0.0. I think this is something which you guys probably are familiar with. Let's do 192.1.10.4, right? Now if we have done all of that, let's check if all the configurations are right. Yeah, so we've got the serial interface up, we have also got the loopback interfaces up, right? And if I also show you how the show IP route, right, we have the default gateway being set to 192.1.10.4. Now we got to repeat the same exercise on R2 and R3 as well, right? So let's do that. So on R2 we got to configure again 2/0, and let's put an IP address of 192.1.20 probably 20.2. let's do 20.2, 255, right? Let's do that. Let's also put the loopback interfaces like we did earlier. Sorry, that's my bad. Loopback, maybe loopback 0, that works. And what do we do here? 10.2.2.2 probably 255 to 5.0, right? No shut. Great. Let's put another loopback, right, which is going to be interface loopback 1. The IP address is going to be 10.22.22.2. right? So we are done with that. Let's also put the default gateway, right? So that's something important. So let's put IP route, right, and that's directed to 192 dot maybe 1.20 and 20.4, because this interface is 20.4, right? So that looks good. Let's just check. Do show IP interface brief. Yep, 20.2, and all of that looks good. Let's also do show IP route, right? And yes, we have the default gateway, looking good. Let's also do the same thing on R3 as well, right? So that's going to be S2/0 and IP address being 192.1.30.3, right? Let's do that. 255.0. Let's do a no shut. Let's also do the loopback. Sorry, interface loopback 0. Let's do a IP address. What do we do here is 10.3.3.3, right? So wait, yeah, so that's good. No shut. Let's do a no shut on that, and let's do the other interface as well, interface loopback 1, right? So IP address is going to be 10.33.33 and 3, probably 255, right? Let's also put the default route. This is IP route, and we are going to point it to 192.1.30.4, right? So I think that's done. So IP interface brief. Yes, we got all of that. Let's also check show IP route. Yes, so that's good, right? So if you look at between R1 and R2, we should be able to now ping 192. So we are on R1 right now. We should be actually able to ping 192.1.20.20.2 probably. Yeah, so there is connectivity between the outgoing interface of R1 and the incoming or serial interface of R2, right, because of the default gateway. Wonderful. But still, obviously, we don't have connectivity between the private networks, which is 10 dot network, so we don't have connectivity between this, and we will sort that out in the next part. Okay, so we have done the basic connectivity now. So now the next step is all about setting up our VPN, right? So the VPN configuration generally has like 5 steps, right? 5 steps, which starts with setting up so the first step is going to be setting up the IPSec or the phase 1. Then we go and set up phase 2, right? And then the third step is deciding on the interesting traffic, okay? And the fourth one would be where we use a crypto map and combine all the 3 steps which we did earlier, right? And then the fifth step would be go and apply the same on a particular interface, right? So let's do that. Let's start with R1. Okay, so I have already got my configuration here on a text file, so I'm just going to paste it, and then I'm going to explain every single piece of what I've actually done, right? So let's do that. So this is my configuration, right? So as you see here, I'm starting with IPSec, the phase 1 policy. So in phase 1 I have 2 policies being set up here, because I want to have 2 separate VPNs between one between R1 and R2 and the other one between R1 and R3. and you see carefully here, one of them is using hash as MD5 and the other one is using as hash as SHA. So I've deliberately changed it, right? And as you see here, we use sequence numbers, that is 10 and 20, right? Because you can have multiple policies being set up on a particular router, so we use sequence numbers to distinguish that, right? And for the first phase 1 tunnel, we need to have some kind of an keying mechanism. So we are using the pre-shared keys. Obviously it's not a very secure way of doing it. Maybe digital signatures would be more better, which probably we can cover it later, but now to start with something simple, we are using a pre-shared key, right? So this is mind you, this is the phase 1 tunnel. This is not the tunnel where we actually encrypt the data. This is just the tunnel which is set up to exchange the Diffie-Hellman keys, which will later be used in phase 2 to encrypt the data, right? So this is that tunnel. So but since it is a tunnel, we need to have the prerequisites, which is my authentication, which is the pre-shared keys, the encryption being 3-des and the MD5 hash, right? Group 2 here basically corresponds to the Diffie-Hellman keys. So there are different groups, and different groups basically generate keys which are of varying lengths. So group 2 basically generates almost secure and decently secure keys, and that's why I'm using group 2 over here. You can try changing the group to different group 5 as well, which basically generates a even lengthier Diffie-Hellman keys, right? So the next part of the configuration is still the phase 1 configuration, where we have I'm setting up the pre-shared keys, right? This is my pre-shared key when I'm talking to 20.2, and this is my pre-shared key when talking to the R3 router, right? 30.3, right? That's good. So these pre-shared keys will actually be used over here to set up my phase 1, right? So till here we did the phase 1 configuration. So now we are doing the phase 2 configuration. The phase 2 configuration is about using the Diffie-Hellman keys which were shared in my phase 1. So I don't have an explicit authentication piece over here like we had over here, right? We don't have that. We just have the encryption, which is 3-des, and the hashing, right? Because the keys will nothing but be the Diffie-Hellman keys or the session keys which were shared in the phase 1, right? So this is my phase 2. Now once we have done that, we need to set up the ACL to determine what traffic we are trying to pass through the VPN, or what kind of traffic are we actually trying to secure, and that basically is defined by the access list. So we have two access lists here, one towards R2 and the other one towards R3. So this is when the communication happens between 10.1.1 network and the 10.2.2 network. So this is the access list 101, and the 102 is between the R1 and R3, right? Now, so we did three different things. We did phase 1 configuration, we did the phase 2 configuration, and we also had the access list to define the interesting traffic. Now cryptomap is actually the command which would put all these three pieces together, right? So again, you can have multiple sections in the cryptomap. That's why we use sequence numbers, right? So as you see on router 1, since you have VPNs towards R2 and R3, we need to, and since there is slight difference with the kind of VPN we are setting up, in one of them we are using a hash of MD5 and the other one we are using SHA. That's why we need to have multiple maps here, right? So crypto maps, so this is basically your sequence number, right? And we are using ISACAM for phase 1, right? So let's just look at this now, right? So this basically is kind of a command which puts together the VPN from R1 and R2, right? So we are telling the cryptomap, hey, please use ISACAM for phase 1, and we are also telling the cryptomap that match traffic 101, which is the traffic going from R1 and R2, and when the traffic matches, the peer or the destination router where the traffic has to be set is basically your 20.2, right, which is your R2 router. And we are also defining the phase 2, we are also connecting the phase 2 configuration which we did over here, and we are connecting the phase 2 configuration to the IPSec tunnel as well. So we have put together everything which we need for the VPN to set up using the cryptomap. and we have replicated the same thing but with a slight difference of this peer, right? And the ACL is also different over here because this is the communication, or this is the VPN between R1 and R3. Wonderful. Now once we have done all of that, we need to apply this VPN configuration on our interface, on the outgoing interface. In case of R1, S serial interface 2/0 is my outgoing interface, and I'm applying it on that using the cryptomap command, right? So let's apply this on R1 now, right? So that looks good, right? Hope everything is good. So we have applied that configuration on R1. So yeah, now what do we do is we go and do the configuration on R2, right? So on R2, what do we have? Okay, let me pull that up as well. Yeah, so we have the R2 configuration. So on R2 we just have one policy, right? Because from R2 you just have one VPN. It's unlike R1 where we had two VPNs. Here you just have only one, so we have only one policy for the phase 1, right? This has to match with what you configured on R1, right? And we also need to have the pre-shared key. Here the peer address is going to be 10.1, right? That's important. Now we also have the phase 2 configuration, right, which we saw earlier. The access list, again very important, but you need to observe here the access list, the source and destination addresses have been reversed, because you know you are looking at the traffic here, which is you know from 10.2 from this network from R2 to R1, right? So that's why the access list has been reversed, because because we're talking about bidirectional tunnel, so R1 should be able to talk to R2 and R2 should be able to talk to R1. So that's why the IP addresses have been reversed here, right? And the next one being the crypto map, like we saw earlier, which combines the above three separate or individual configuration, right? It puts together your access list, it puts together your phase 1, it puts together your phase 2, all of that bundled up here. The peer is again 10.1, right? And the interface on which you're applying this is again your 2/0. So let's apply this, right? And you can see the IPSec is on, right? So now how do we check if the tunnel was established? So what do we do is we run a couple of show commands. Let's do that. Let's probably do that on R2, right? You can do that. So let's do show crypto IPSec SA. So this basically helps us understand the phase 1 communication. Right now there is nothing because the output is empty, because we did not have any traffic going from R2 to R1. So as a result of that, the tunnel, the phase 1 tunnel and the phase 2 tunnels were not created, right? So what we'll do now is we are going to generate some traffic. And how do we generate some traffic? Using the ping, right? So let's generate some traffic towards R1, so which would be 10.1.1. let's do source it from 10.2.2, right? Okay, I think I should have done a ping. Yeah, so we generated some traffic. Now let's go back and recheck the show command. There you go, we have something up here. So the phase 1 tunnel has been set up, it is active, right? And now how do you check the output of the phase 2 tunnel, right? So we do the show command, do show crypto and IPSec SA. SA basically stands for Security Association. So there you go, we have set up the tunnel. So you can see the output over here. It clearly tells us that 4 packets were encapsulated, 4 packets were encrypted and sent across to the router R1, right? So we have 4. Why is it 4? Because as you see here, there were 4 packets which went to the other side, right? And what else can you see from here? This is so the this particular number which I have highlighted is basically the ID of the Diffie-Hellman key, right? Which is used for the key, basically, which is used for the encryption of the data as it moves between R1 and R2, right? So we could look at the same output on the other side, which is my R1, right? So let's look at the same on this R1 side. So if you see here, let's go back to R2. So on the R2 you had you have two keys, right? You have two keys over here. Let's look at the outbound key of R2 is going to be the inbound key of R1, right? So where is my inbound key over here? I have to go down. Yeah, so this is my inbound key. If you observe, the outbound key here ends with 9028, and if you go to R1 and you see the inbound key is 9028, right? So what I mean to say here is that the key, this is obviously not the key, this is the key ID, but it's the same key, right? The key which I'm using to encrypt the data on the outbound interface on my R2 has to be the same key which I'll use on my inbound interface of R1 to decrypt it, right? So if I go down and show you this, the outbound key on R1 will be same as the inbound key on R2, right? So we actually set up a tunnel between R1 and R2, or a VPN between R and R2, my bad. Now what we'll do is let's do it on R3 as well, right? Let's look at R3 as well. So we have already done the configuration on R1 side, we just need to do it over here. So if you see the configuration, again we have the phase 1 configuration, right? With my pre-share, 3-dash, SHA and the group, right? We also have a pre-shared key. This is my phase 2 configuration, and I also have my access list set up here, and the access list goes from 10.3.3.0 network towards, because we are talking about encrypting the data from R3 to R1, right? A VPN from R3 to R1. And we have my crypto map, which is putting together everything into perspective. We have your phase 1 here, we have the ACL, we have the peer, we have the phase 2, and this is the interface on which we are applying. So let's say I apply this over here, right? We've done that. Now let's see if we can check the output of do show IPSec, or let's see the first one, right? Do show crypto ISACamp SA. So there is nothing now. Let's ping. Let's do a ping. Do ping 10.1.1.1. Let's source it from 10.3.3.3, right? Yeah, the ping went. Now you can see the output of ISACamp SA, and you see that the phase 1 tunnel is active, right? And we can also see the output of phase 2 tunnel. Do show crypto IPSec SA. So you can see here the packets, 4 packets were sent, right? And there is like a inbound key, and there is an outbound key as well, right? So what we did in this exercise was that we established we used R4 as my ISP. We established VPN between R1 and R4, and we established a VPN between R1 and R3. There was a slight difference between these two VPNs. I used a different hashing algorithm in my R3, which is I used the SHA over here, I used the MD5 over here. But basically we had like 2 VPNs coming out from R1, one towards R3 and R2, and we also saw that it's actually working. We saw the outputs of both the phases, and we had the packets encrypted and sent across, right? So that was a basic configuration which I wanted to show you. Tune in, maybe we'll look into more VPN stuff in the coming videos, right? Thank you.